Today's video is going to cover solving systems by graphing. This is the third method. In which you can solve systems. And it will be the last method you learn. So before we begin, you've seen three different types of systems problems. You've seen ones that are set up like this. You've seen ones in standard form. You've seen ones in slope form. You're going to now, after this video, know three different methods. So each of these forms is set up to be solved most efficiently using a different method. You can solve any of these systems using substitution. You can solve any of these systems, any of these three problems using elimination, and you can solve any of them using graphing. However, they're all set up for a specific type. So for this first one, the best way to solve it is using substitution, because you would just take what y equals and you would substitute it in for y. This second type of system is best set up for elimination. When they're in standard form, where x's are lined up, y's are lined up, and constants are lined up, it's best set up for elimination. And then this third form, when the equations are in standard form, slope-intercept form, it's best set up for graphing. But we've learned that you can kind of pick and choose which method you like the most. So let's go over example number 1. You can see that both of these equations are in slope-intercept form. And when they're in slope-intercept form, it's really easy. So the first step in solving using graphing is to convert them into y equals. Well, both of them are in y equals. You can see that right here. You have y equals and you have y equals. So first step, you're good. Well, the second step is to graph using the calculator. So I'm going to pull up the calculator right now. And here we have the calculator, and I'm going to move it down just a little bit. So what you're going to do is you'll see the scientific, you'll go to graphing, and then you're going to see this this graph right here, and you're going to see this word expressions where it says the y equals. You're going to type it right here, and then the y equals is given to you. Y equals -4, so we're going to type in -4, x minus 1. That's the first equation. The second equation, we're going to move into the y2, and we're going to type in x plus 4. Verify you typed it in correctly, and then you're going to hit graph. So once you graph, okay, the third step is to look for the point of intersection. So I'm going to go back to the graph, and you can see right here the graph, the two lines are intersecting, and it looks like they're intersecting when x is -1 and y is 3. But you've got to make sure. So we're going to use the trace feature, and what this trace feature allows you to do is by clicking side to side, it allows you to trace up and down the line. So I'm going to trace all the way until I think I'm on the intersection point. Now this blue dot is for the first line. See how it says y1? That was the first equation that we typed in, that y1. So this blue dot is on the first line. Now if I hit this up and down, you see that the blue dot's moving from the top to the bottom line. So right now I'm on the second line. Now if I hit the down, I'm on the first line. So I'm scrolling up on the first line all the way until I feel like I'm in the middle. And now what I'm going to do is I'm going to hit to the next line to see, is the coordinate point the same? If it is, then that means that we found the exact point. So you can see that when I'm on y2, y2 equals 3, x is -1. When I hit down, x is -1, y1 is 3. So it's the same coordinate point for both of the lines. That means that's the intersection point. But we're going to verify that in the table to make sure that the coordinate point is in fact -1 for x, 3 for y. So I'm going to click table, and this allows you to type in the x value. So you can see here we've got our x value. When x is -5, the first line is at y19. The second line is at y-1. But when our intercept is -1 for x, we're going to type -1 in for x, and we're going to hit enter, and we're going to see what the y values are. So when x is -1, For the first line, y is 3. For the second line, y is 3. You're looking for the double y. That is the intersection point. So I know that this line right here, these two systems, the solution is -1 for x and 3 for y. Now for the second example. So here you can see that the equations are not in slope-intercept form. So our first step again is to convert the equations to y equals. And so all we're really doing is we're solving for y in the first equation, and we're solving for y in the second equation. So we've got to eliminate the variable term x, and if there's a number or coefficient, that. So I'm going to solve for the first one. So we've got 2x plus y equals 2. I'm going to subtract 2x. I'm going to subtract 2x. These are gone. Positive y is just y, so we've solved for y. And I can just leave it like this. I do not need to convert this into slope-intercept form. I can just leave it as y equals. Now for the second one, we've got x plus 3, y equals -9. So again, I'm going to subtract the x term, so minus x. Why did I write that? Minus x. These are gone. We're left with positive 3y equals. So we're going to divide by this positive 3. So we're going to divide by positive 3, divide by positive 3, divide by a positive 3 to both sides. So both terms on this side, so that the entire side is being divided by 3. Then we're left with y equals. I'm not going to simplify any of the fractions. I'm just going to leave it as like this. Minus x divided by 3. So we've converted both of these into y equals. Now the second step here is to graph using the calculator. So I'm going to pull up the calculator. I'm going to go back to graphing. I'm going to hit the expressions. I'm going to reset everything, and now I'm going to type in the first one. So we've got y equals 2 minus x. 2 minus 2x. And for the second one, we've got -9 divided by 3 and -x divided by 3. So minus x divided by 3. They're both in. We're going to hit graph. And now you can see that it looks like they're intersecting when x is 3 and when y is -4. But I'm going to trace. Whoops. I'm going to hit the trace feature. I'm on the first line right now. I'm going to trace all the way down. I'm going to trace all the way down to the center. So it looks like I'm pretty much on that point. I'm on the first line. I'm going to switch to the second line. And it looks like the coordinate point has not changed. Looks like the coordinate point is 3, -4. So I'm going to go ahead and write that here. 3, -4. But I'm going to make sure to verify that in the table. So I'm going to hit the table. When x is 3, are both of the y values -4? When x is 3, both y values are -4, so that is in fact the point of intersection. So our answer here is 3, -4. Here is the last example today. So again, they're not given to us where y's are. Actually, this one already is solved for y. So this one we don't need to do anything. But step 1 is we're going to convert them to y equals. So if we're looking only at the first one, we've got 0 equals -y minus 2 plus 2x. And we're trying to get just the y. So we want to eliminate these numbers, and we've got to eliminate this negative sign in front, but we'll save that for last. So let's first start by eliminating the x term. So it's being added. We're going to subtract. That is the inverse. Make sure to do it to both sides. And we have -2x equals a -y minus 2. We can eliminate the -2 by adding 2 and adding 2. These are gone. Now I cannot combine these because this is a -2x. This is just a number. So I'm just going to write it like -2x plus 2 equals a -y. And now I need to get rid of the negative. I know that there's a 1 in front of the y, so I'm going to divide by -1. I'm going to divide by -1. I'm going to divide by -1. What I'm left with after I divide, I have, and I'm going to write it right under it. So I'm going to have negative divided by negative, or we don't even have to simplify it, but we could. Negative divided by negative, we're just switching the sign, so we've got 2x minus 2 equals y. So we've converted this top equation to y equals. This bottom equation is already in y equals, so now we're ready to graph. Go back to expressions, reset it, move this over a little bit so you can kind of see still. So our first equation is y equals, and then it doesn't matter which way we write it, 2x minus 2. 2x minus 2. I can move the y over here if it helps some of you guys. We can say y equals, right? We can say y equals like that. We can switch the sides of the equal sign. That's not a property or anything, that's just moving it. And then the bottom one, negative x plus 4. Hit graph. Looks like the point is at 2 on x and 2 on y. Let's make sure by tracing. With the trace feature, I'm going to trace all the way up. I'm pretty much on it. It looks like 2, 2. Let's switch to the second line. 2, 2. So it had not changed. Let's just verify in the table. So when x is 2, are both of the y values 2? Apply. When x is 2, both y values are 2. That is our solution. So we can say that x is 2, y is 2 is the solution to this system. If you have any questions, please email me or message me in Schoology or consult up here. Good luck on the homework.